Hello friends, welcome to my YouTube channel Physics Scientists. Please like and subscribe to my channel. Today let's talk about what is graphene. Today our topic is carbon nanostructures that contains buckyballs, carbon nanotubes and graphene. What is graphene? Graphene is made of a single layer of carbon atoms that are bounded together in a repeating patterns of hexagons. Graphene is 1 million times thinner than paper, so thin that it is actually considered two-dimensional. Carbon is an incredibly versatile element depending on how atoms are arranged. It can produce hard diamonds or soft graphite. Graphene flat honeycomb pattern grants it many unusual characteristics, including the status of strongest material in the world. These single layer of carbon atoms provides the foundation for other important materials. Graphite or pencil lead is formed when you stake graphene. Carbon nanotubes, which are another emerging material, are made of rolled graphene. These are used in bikes, tennis rackets, and even living tissue engineering. Graphene is the two-dimensional crystalline form of carbon whose extraordinary electron mobility and other unique features hold great promise for nanoscale electronics and photonics. The only problem with graphene is high quality graphene is a great conductor that does not have a band gap. Therefore, to use graphene in the creation of future nanoelectronic devices, a band gap will need to be engineering into it, which will in turn reduce its electron mobility to that of levels currently seen in strained silicon films. As with the monolayer graphene, bilayer graphene also has a zero band gap and thus behaves like a metal. But a band gap can introduce if an electric displacement field is applied to the layers. The material then behaves like a semiconductor. Let's talk about how was it discovered. Graphene was first studied theoretically in 1940s. At the time, scientists thought it was physically impossible for a two-dimensional material to exist due to thermal instability when separated, so they did not pursue insulating graphene. Decades later, interested pickup researcher began dreaming up techniques to peel apart a graphite. It's actually become possible due to the fact that the carbon-to-carbon bonds in a graphene are so small and strong that they prevent thermal fluctuation from the disturbing it. In 2002, University of Manchester researcher Andrew Jim became interested in graphene and challenged a PhD student to polish a hunk of graphite to as few layers as possible. The student was able to reach 1,000 layers but could not hit Jim's goals of 10 to 100 layers. Jim tried a different approach. He applied it to graphite and peeled it away to create a flax of layered graphene. They published their findings in Science in October 2004, and Jim and his colleague received the Nobel Prize in Physics in 2010 for their work. Let's talk about graphene production. The quality of graphene plays a crucial role as a presence of defects, impurities, grains, boundaries, multiple domain structural disorder, wrinkles in the graphene sheets have adverse effect on electronic and optical instrument. In electronic application, the major bottleneck is the requirement of large size samples, which is possible only in the case of chemical vapor deposition (CVD) process. But it is difficult to produce high quality and single crystalline graphene thin films possessing very high electrical and thermal conductivities along with the excellent optical transparency. And therefore there is a need to develop green methods to produce graphene by following environmental friendly approaches. Thank you very much. If you like my lecture, please like and subscribe to my channel.